Alright guys, for the second question, you really need to be very familiar with your VSEPR in chem bonding. Okay, so I've highlighted all the atoms, right, that you're supposed to see if there's an increase in the bond angle. So the first option, A, silicon trioxide, actually is trigonal planar. If you want to quickly draw it out, you can, because it has two minus, right? So it looks something like this. You got to quickly deduce that it is trigonal planar and has a 120 degrees bond angle. Okay, then for the silicon with 6 fluorine, this is the shape. Okay, so two of the bonds are actually dative bonds. Two of the bonds are actually dative. Doesn't really matter for the bond angle. So the bond angle here is 90. Okay, so it actually gotten smaller from 120 to 90. So this is not our answer. And similarly, we're going to do the same for NH2. Okay, so NH2 minus, right, is actually from NH3. Okay, so we'll draw NH3 first. This is our very familiar ammonia, trigonal pyramidal 107 bond angle. If you take away one of the H, right, one of the H plus, you actually get two lone pair with a negative charge. Okay, so this is band 104.5. Okay, so the bond angle is the same as water actually. And then BH3 boron is electron deficient, so it has 3 bond pair, 120. BH4, you just need to dative bond a H minus to it, so this is tetrahedral. Okay, so the bond angle is getting smaller. Okay, so C is not answer. B is in fact our answer, by the way. D, right, hydrogen peroxide. No, not hydrogen peroxide, sulfur dioxide. It's the same structure as this one here, and with a lone pair. Okay, so this bond angle is 119. Sulfuric acid, you just need to put a sulfur in the middle, double bond O, dative bond H. Sorry, this one not dative bond, this is a normal bond. Okay, so tetrahedral also 109.5. Okay, so if you're thinking of the angle at the oxygen instead, it is 104, but that's not relevant because we are looking at the sulfur. Okay, so D is not our answer as well. The only one which increases in bond angle, you can see very clearly, is